Laura. Um, so um, I'm just going to give a very quick overview here of the school. So we are the School of Electrical and Electronic Engineering. Our ranking as a university, University College Dublin has a ranking as of 2026 of 118 in the world. So the school is divided up into a number of sections. There are two sections that are of particular interest to you today, which is the electrical engineering section and the electronic engineering section, but I'll also mention the other major academic section, which is biomedical engineering. So in terms of the um, sort of research of the school, we have research in the area of electronic engineering, which I'll discuss a tiny bit more later, in the area of electrical engineering, in the area of biomedical engineering, and then we have some kind of cross-cutting areas as well. So there's a great deal of research in the area of quantum engineering, particularly amongst the electronic and the electrical engineers. There is a great deal of research in the area of signal processing. That's really in all three areas, but especially in electronic engineering and biomedical engineering. And there is quite a bit of work being done in the area of AI and machine learning. And that's really all areas that have a great interest in that particular space. So in terms of biomedical engineering, the ME biomedical engineering we're not talking about that today, but that is our master's in biomedical engineering. And the work that they do, which is possibly of interest to a number of you, so they have across the board in terms of biomedical engineering. So those that are involved in neuroscience and cognitive modeling, those that are involved in research into areas such as sleep apnea and gait analysis and speech analysis, those that are involved in neuromodeling and neuromuscular modeling, and then those that are involved in prosthetics and rehabilitation and robotics and sensors and wearable devices. These very much are cross-disciplinary with especially electronic engineering. An area of interest here is the electrical engineering section. So the head of subject is Professor Damien Flynn. We have some program directors here. These are from the two programs of interest here, the ME Electrical Power Engineering and the MNGSC in Electrical Power Networks. So the general areas of research for electrical engineering, Ireland is an important place for renewables, especially for wind. So there's a great deal of interest in essentially grids that have a lot of renewables, so low inertia power grids. So there are people who are interested in modeling and the control and stability analysis of such grids. There are those that are involved in sort of the modeling, but also the grid operation and the planning of new grids, and also the electricity market. And increasingly of interest for us is offshore grids in the country of Ireland, because there's a great deal of wind energy available offshore. And then there are those that are involved much more in the technology. So the technology of charging of EVs, so power electronics, energy harvesting, and those are their main areas. So in electronic engineering then, head of subject is one of the program directors with us today, Professor Peter Kennedy. Of interest here are the two ME, the ME in electronic and computer engineering, and the MNGSC in electronic and computer engineering. So there's a very broad range of research engaged in this area, but I think it's probably could somewhat say a lot of it is towards 5G and 6G, and particularly Internet of Things, and generally delivery in that particular space. So you have those that are involved in quantum, those that are involved in literal just IC design, both silicon and gallium nitride, those that are involved in the wearable sensors area, those that are involved in more higher level models of the circuits, the chips that have been manufactured, all towards basically enabling essentially Internet of Things. So that's an overview. So thank you for your interest today. And I will now hand over to those various others that are going to talk about the specific programs.
Great. Thank you so much, Paul. Really appreciate that. So we are going to hand over now to Professor Mark Flanagan, who is the program director for our two-year program, our ME in Electronic and Computer Engineering.
Thanks, Laura. Okay, so I'm just going to say a few words today about our ME in Electronic and Computer Engineering. I'm the program director for this program. It's a 2 years full-time master's in electronic and computer engineering. So this particular master's kind of, let's say, bridges the hardware and software aspects, which are both equally important, I would say, for, if you're going to work in the area of electronics, communications, and computing in the modern world. In terms of modules, we have a range of many different modules to choose from, some of which concentrate on the hardware aspects, the more traditional aspects, such as analog and mixed signal IC design, digital design, things like embedded systems, and so on. But then we also have quite a strong concentration we bring in on the software side, things like software engineering, which is one of our core modules, and also options in, for example, data science. And I would say in general, there's a strong programming aspect throughout. You develop strong programming skills, I'd say, throughout all the modules you'll do in this particular program. On the other side, then you've got the algorithms, which is things like, the machine learning, signal processing, quantum computing, and other related modules where you can develop algorithm skills. And again, all of these fields are somewhat complementary in the modern world, where we have challenges such as development of 6G network, the Internet of Things, the explosion in AI, and also new emerging technologies such as quantum computing. And I would say in terms of the modules you choose, okay, some of these modules are core, as in they're important enough that everyone needs to know them in order to graduate the degree. But some, of course, will be optional, and there's enough of a range of options that you can kind of tailor your interest, or if you like, you can create a suite of modules that is more tailored. Let's say if you're interested in the hardware side, you can be more in that, more concentrated in that area. If you want to go more in the software side, you can do so, and the same thing with the algorithms and so on. So you can kind of tailor the degree to suit your own particular educational needs. One thing I should mention about the ME program, common to all of our ME programs actually, is that we have a work experience built in. So in the 2 year program, after your first semester, where you will do 6 normal modules, the second trimester, which is in the spring, will be taken up completely by work experience. This is replacing the normal module content. And what it means is that you're placed in a company for that time where you'll work under the supervision of an industry partner. It will be, let's say, arranged by UCD, so we will arrange the placement for you, but at the same time, you need to actually develop your CV and do the interview, in other words, qualify for the position. And this is done with the support of our staff here. So we will actually develop your CV writing skills, your interview skills. Again, important things to actually know when you are going for a job after the degree is complete. So one thing I mentioned here is that we're lucky in Ireland to have many of the top companies here in Ireland to serve our needs. In this respect, we have, for example, AMD, Intel, Analog Devices, IBM, Infineon, and so on, many more companies, all of whom we have graduates there at the moment on placement. And one thing I'd mention is that in general, these companies are very happy with their graduates. They're very happy with the standard of the ME students. And in fact, it's quite common that students will get an offer during their placement to come back to that same company after they've completed their degree. And this doesn't happen in every case, but it's certainly more than half of the students will get such an offer, which is obviously very good from our perspective. One other point I'd make is in the second year, the major, let's say, component would be the ME project. This is a major project which takes place during the autumn and spring trimesters, so it runs throughout the academic year. And it's a step up from, let's say, most bachelor's levels projects, in the sense that there's a very strong research component. So you're expected to get into an area. You basically pick your project from a list of projects which are published by the staff. Again, usually aligned with the research areas of the staff, some cutting edge topics they want to work on. And the idea then is that you would get running on such a project. And the idea would be very much that you would innovate in these areas. So it's about understanding and reading the current literature, the state of the art in the area, trying to go beyond the state of the art, come up with new ideas, again, with the help of the academic involved, but trying to really push the boundaries of what can be done in these areas under the supervision of the academic. And just to give you an idea of the research challenge involved, one of the deliverables for this project is a conference paper. In other words, it's to deliver a paper that could be submitted to an international conference. And in fact, in many cases, these papers are actually submitted to international conferences and are attended by the student. So that's just to give you an idea. It's about doing innovative research, and it's about developing your research skills. So it's a higher level than most, let's say, bachelor's level projects. And again, in terms of the topics you might end up working on, anything from Internet of Things, quantum computing to signal processing for communications, power amplifier design, etc. We have quite a large coverage of such topics. Okay, so I think I'll just hand over to Professor Kennedy, who's going to talk about the MEng-SC.
Thanks, Mark. The MEng-SC, Electronic and Computer Engineering, T257. This one is designed for graduates, so people who have already completed a 4-year undergraduate degree in electronic engineering, typically, and it's a 1-year intensive program. So the program structure, it's 12 months in 3 equal pieces. In the autumn, there's 30 credits of coursework. That's 6 modules. Spring, there's again another 30 credits, 6 modules. And in summer, a project that is worth 30 credits. We've organized it into thematic pathways. So if you'd like to specialize in communications and signal processing, there's a set of modules that we would recommend. Computer engineering, another set of modules we recommend. Electronic circuits, we're now building that out even further. And from this year, we'll be including mixed signal verification. And then we've a new thematic pathway in quantum engineering that you will be able to follow. So the first trimester, you pick 6 modules. On the left-hand side, you have the core modules, and you pick 4 of those core modules. So for example, if you're on the computer side, you might like to do software engineering and algorithms. If you're on communications and signal processing, maybe you do digital communications, advanced signal processing. On quantum, you'll do the quantum and machine learning. And then if you're in circuits, you maybe do analog integrated circuits and so on. So you pick at least 4 from the left column, and the 2 can be any of those on the list. You'll see that there's a very wide selection to choose from. But we bundle them into the appropriate pathways, so we'll guide you in that choice. In the spring trimester, then again, if you're following the quantum pathway, you have quantum computing, quantum machine learning. If you're following integrated circuits, you'll have mixed signal circuits and verification. If you're on the software side, you'll do the deep learning and Python, for example. But again, there's a large selection of modules to pick from. Over the summer, you do an intensive 3-month project supervised by 4-month project supervised by one of the academic supervisors. And again, these are in different areas. There's some in the signal process area, some in integrated circuits. There's a very large variety of projects available. At the end of your studies, all students, international students in particular, are entitled to work in Ireland for 2 years after they complete a degree in the country. So on completing this program, you're eligible for all the jobs that are available in Ireland. And in particular, if you've an interest in the circuit design space, this industry body, Midas Ireland, always has a running list of jobs that are available in the areas that we'll be preparing you for. Okay? And I'll be happy to answer questions at the end. Back to you, Laura.
Great. Thank you so much, Peter. So next up we have Associate Professor Terence O'Donnell, who is the Program Director for our ME, our two-year program in Electrical Power Engineering.
Terence, I think you're muted there. We can't hear you. My apologies for that. I was muted. Okay, so I want to give a brief introduction to our two-year master's program in electrical power engineering. I guess by way of background to this program, most of you are probably aware of the sort of urgent need to do something around climate mitigation and the consequences for the, I guess, energy system arising from that, and in particular, the emphasis on the move away from conventional fossil fuel-based generation in the electrical system towards renewable energy. And indeed, also, it has great consequences for other sectors such as transport, which is, there's a big focus there on electrification of transport and the introduction of electric vehicles. All of these things, I guess, have very significant consequences for how power systems are being planned and operated. And that puts, I guess, electrical engineers with a good background in power systems very much at the forefront of that transition, that energy transition. And I guess this two-year master's program is really aimed at giving people the skills to understand, I guess, the knowledge and the skills to understand, the role of the power system and power system operation and planning in the energy transition. So as I say, it's a two-year ME program. It's providing an advanced engineering education in subjects such as power system analysis and design, power electronics and their applications. So power electronics is particularly important for the power system going forward because most renewable energy is connected to the power system through power electronics converters. Big emphasis on topics such as sustainable power systems, renewable energy, and electricity market operations. The program, as I say, is a two-year structured program, similar to the structure of the previous two-year program talked about by Mark. So it's got, in year one, you will do in the autumn trimester 6 top modules. In the spring trimester of year one and the summer trimester of year one, there will be an organized work placement. Again, as Mark referred to earlier, organized by the university here. In year two of the program, you will typically do in the autumn trimester 4 top modules, in the spring trimester 3 top modules, and then in parallel with those over both the autumn and spring trimesters, you will do a research project. It's your main thesis project. And again, it will be based around topics of interest to the academics here in the school. And as Paul mentioned earlier, in relation to the school, there is a strong, I guess, research group here in the area of electrical engineering, and in particular interested in the integration of renewable energy into the power system. Our graduates, I guess, will take work placements with a range of different companies. So we have companies, I guess, in the power system operation area. So power system operators like in Ireland, such as EirGrid and ESB Networks, are the transmission system operator and the distribution system operator in Ireland. We would also have a range of companies more on the sort of energy suppliers or renewable energy developers side. So companies such as Energia or Electric Ireland. Also a range of companies in sort of the power systems equipment and monitoring side of things. So some of the bigger names, that internationally known names that you might recognize there are companies such as Hitachi Energy or Infineon or Eaton. So our graduates, well, during the master's program, we had work placements with companies like this, and it's quite often the case that graduates would then go on to actually get a position with some of those companies. So that's a very brief overview of the program. Again, I'd be happy to take questions at the end. And I think now I will pass over to a colleague, Paul, who will talk a little bit more about the 1-year program in electrical engineering.
Super. Thank you, Terence. So yeah, just like we've seen, the pattern is that there's a 2-year version and a 1-year version. So I'm the program director on this MEng-SC, so the 1 year, a little bit more focused into electrical power networks, which again is trying to create graduates that have the skills that can go in and work for grid operators and anyone who's feeding power into the grid or who's taking bulk power out of the grid. So the grid is not going anywhere. It's absolutely essential to the modern economy that we can move lots of electric power around our country. So this is a focused 1-year offering on exactly the skills that are relevant to that. So what have we got at a glance? So 3 trimesters in a row, good and busy, good strong sprint. And as I say, the focus is on the design and operation of electrical power networks. And it's going to suit someone if you've got a 4-year engineering degree in electrical, electronic engineering, or energy engineering, or a closely allied field, but you've come across electricity certainly before, and you want to move into this utilities space. That's who we're targeting it for. So a much more straightforward structure, I think, than Professor Kennedy was showing the different pathways through his 1-year master's. I'm afraid here we only have one pathway. It's a simpler structure in that sense. There's less choice. So in the autumn trimester, we have 4 mandatory modules here, which are the foundations of the discipline. These 2 here will be absolutely key: power system operation and power system dynamics and control. Power system here referring to the national grid. Optimization is essential in understanding how electricity grids operate, because that's how you make your decisions. Which generators are you going to turn on or turn off from hour to hour throughout the day? That's all lots of optimization problems. So very foundational of the field. And then here we've got 4 more technical modules, and you have a choice of 2 of those 4. Some little ability to steer your interests, but not a huge amount of flexibility. So that's your autumn trimester, 6 core technical modules, keep you good and busy. Here in spring, well, lots more technical modules to do. So everyone's going to do these 2 here. So power system design, obviously quite foundational to the topic. Applications of power electronics. So that again is very much focused on the national grid and equipment that we can put into the grid to improve its operation, which is based on power electronics. So everyone's going to do that. Then here we have a slate of 5 more modules, again, technical modules that are complementary to understanding how the grid operates. You're going to choose at least 3, maybe 4. So you can pick 4 from this slate and do your 2 from there, and that's your 6 for the spring trimester. We also have some professional development modules, to broaden it out just a little bit, to round you out as a professional engineer. So an excellent module there in technical communication. Increasingly in the modern grid, you have to bring stakeholders with you. Modern power grids are privatized. There's lots of different entities that are operating the wind farms and the solar farms and the batteries. So there's a lot more stakeholder management involved to get things done. So we believe that technical communication is very helpful there. It's a very good module. It gets good reviews. And likewise, the management piece for professional engineering, project management and everything else comes into this. So you have the choice to do 0 or 1 of those modules. You can't do both. So that's your spring trimester. And then we get to our summer trimester. And again, you'll be working right through the summer. And like has been described previously for the other programs, it's a case here where my colleagues in the electrical subject area will propose a slate of projects, mirroring their own research expertise, mirroring genuine problems in the sector, so, up-to-date issues that are happening on power grids, and we're trying to get to grips with them. And you'll engage individually with a supervisor. And that was one of the questions in the Q&A. Are the project individual or group work? They're individual. So it's a one-on-one relationship between the student and the supervisor, generally meeting at least once a week to make forward progress on that project. So in the case of this summer project, it's again quite a simple structure. There's just one deliverable. At the end of the summer, you write a dissertation that documents your work, and that's graded by someone other than your supervisor. And there's an interview that you can stand over the work, and then that's your summer. Is all research. So it's a capstone. It's substantial, and if you pass it, then ta-da, you get the master's. And like my colleagues have mentioned, that entitles you then for 2 more years of work, in Ireland's growing and vibrant electrical engineering sector. So that's that. Thank you.
Great. Thank you so much, Paul, and to all our speakers for giving a quick overview of the presentation of the programs that we have on offer within this particular school. So we are going to move on now to our question and answer session. So I've seen that a number of people were typing in Q&As in the Q&A box that I said at the start, which is great. So we'll get through as many of them as we can now live, which will be great. Just to highlight, if your question is related to a very specific question related to your application, just to let you know that my colleague Katie will pop her email address and my own email address in the chat. And I just request that you send us an email after the webinar today with your specific application ID number, so we can follow up directly with you, whether it's related to a status of your application or moving a deadline or anything like that. If it's very specific to your application, we'll follow up with you after the webinar today. So get your questions typing in there. We'll get through as many as we can. I know some of my colleagues were answering some of them already, so I'm just going to pull some of those just in case anyone else is interested in those particular answers. There was one just relation, I know, Paul, you answered in the chat, relation to the research project is an individual or group. And if anyone wants to jump in just to highlight maybe how those research projects are assigned, can students pick their own topics? Are they given topics? And how that maybe just to expand on that a little bit, how the research project works.
I would say for the MNGSC Electronic and Computer, we come up with a list of projects. The students bid for those projects. They rank them in order of preference, and then based on their performance during the year, the projects are assigned.
Great.
Maybe just to add a little bit to that for the ME programs, and this would cover both the ME in electrical power and the ME in electronic. There is also, mostly it works as Peter would have said for the ME projects. There is, however, an opportunity also sometimes for people to propose their own projects, particularly if they have done something during their work placement which has inspired some ideas in them as regards research projects or aspects of something that they would like to follow up on. There is an opportunity or a possibility that they can also do that.
Great, thanks very much.
And sorry, I'll just add to that.
Yeah.
This, because it's related to another question that was asked. This year we had a French student who proposed their own project in the MNGSC, and they also wished to do it while on a placement with a future employer. And so we have permitted that as well. So there's some flexibility there.
Great. And then Peter, just sticking with yourself, I know you were, I think, responding to a question in the Q&A box. Regarding the curriculum for your program, how much flexibility do students have in choosing elective modules? And I suppose this particular student was looking for a focus on advanced machine learning applications and electronic systems.
Okay, we have those programs. I would refer them to the description of the MNGSC, and I gave a link to that. Maybe you can follow up. But look at what's available. We have core modules, that some of which they must pick, and then they'll see from the other list, do they find things that they like.
Great, that's brilliant. Thank you very much. And then there was, again, Mark, you answered this one, just for anyone else tuning in. Do you have to be in Dublin for your research project? And I suppose to expand on that, how much, I suppose, contact hours and time do you have to be on campus for your programs and the project?
Maybe I'll take this one since I answered it online. So in general, it's a full-time in-person attendance masters, right? So in general, you need to be on campus for lectures, for labs, things like that. So you need to be around. When you're doing your research project, you'll also be doing modules. So of course you'll be there and so on. And the internships are by and large usually based in Ireland, and most of them are based in Dublin. I suppose in principle it's possible that I think we have had one student abroad recently who did their project in the UK. That's possible if it comes up, if things work out that way, but it's not necessarily the most convenient. So it's for a student or for a supervisor and to stay in touch. But again, as Peter said, there's flexibility. If things work and there's a case or something, we're open to things like that. But in terms of just attending lectures, doing labs, doing assignments, and all that kind of stuff, very often you need to be in the country. Even to discuss with your supervisor, it makes sense to be able to do that face to face. So we do have an emphasis on attendance, in person, all that kind of stuff throughout the program.
Brilliant. Great. Thank you, Mark. And then someone was just, I suppose, asking about the work placement aspect. And just to highlight, our MNJCs, our one-year programs, do not have a work placement component included, but our two-year programs do. How does the placement work? How do students secure their placement? And is there any issue with or an instance where a student does not get a placement offer, and what happens then?
So this is for the MA, the question is this point, is it?
I think this point was that someone was asking about electronic and computer engineering. Yeah.
Yeah, so if it's for the ME, then yeah. So the way the placement works is, again, as I mentioned, it's kind of like it's like a competitive process, the same way it would be in the real world if you're going for a job after graduation. But of course, we don't throw you to the wolves exactly like that. So we take care of the internships are organized in the sense that we have a list of companies who are basically looking for interns, and of course, it's a matter of filling those internships. So basically, what happens is you do have to prepare your CV, you do have to do the interview. You're given help internally from UCD with that, which of course is good for your general education. But then in terms of the competition, yeah, you basically rank or you apply to the internships that you want most and so on, and you go and do the interviews. And it's not all completely handheld, so you're not guaranteed to get exactly your very top choice, but that's more like the real world. So I mean, we have to go along this line. In terms of not getting internships, so it's our responsibility to make sure students are placed. It can be that in some unusual circumstances, it'd be quite rare, but in some cases, if a student has some trouble, we always have the option of placing a student within one of the research groups in the school, which again, that's a kind of a similar, because it's a bit more research intensive, but otherwise kind of similar enough to the industry environment. Some of our research groups will be quite run in that kind of way anyway. But again, this would be quite rare, and in most cases, it's a matter of which internship you get at the end of the day.
Maybe I might just to add to that,
Yeah,
just to allay any concerns. Like, I think in UCD we do a great job of arranging these internships. There are two people. There's a dedicated office in the college that curates the internship experience. So it's not that we just sort of have this chaotic, open-ended, leave students their own devices. Perhaps some worse universities do it that way. That is not the way it's done here. There are administrative professionals who curate and manage the whole pipeline of lining up those internships, so it works quite well.
Great, thank you very much. There was just a question. A student has an offer for one of our programs, so congratulations. They haven't specified which program, but they did say they have a background in computer science with a strong focus in IoT, and they're just wondering about, are there any specific lab facilities or research groups within this particular school that focus on hardware, software co-design for master's level students?
On that one, I would say,
Yeah.
okay. So on that one, we have an embedded systems module, which is being made compulsory for all our own students. It used to be optional in the past. So we're putting a lot of emphasis on embedded systems. And so the hardware, software co-design is part of that. Because of the demand from industry, there's a huge demand for verification. So we've developed a new module in consultation with industry on mixed signal verification, and that will be rolled out and available from January 2027. So yes, in terms of hardware, software co-design, we have a number of modules and research projects also running in that area.
Brilliant. Great. And then this particular student had a couple of questions. They look like they're an applicant for one of our programs. Again, they didn't mention which one. Is there any specific technical skills or software tools that you would recommend for any students starting your particular programs that they could do to ensure a smooth transition into the engineering modules that they will take within your various programs?
Perhaps I'll answer for the electrical power masters. We do have a requirement that students coming into the electrical power masters have done some modules in some of the what we would consider the basics of electrical power. So we require some students to have done some modules in electrical machines, which we consider to be a fundamental, and also some background in power system analysis. But yeah, those I guess are just sort of some basic requirements that we would have for the electrical power side.
Great. And then they were also just saying that Ireland has a strong tech ecosystem, which is great. Does UCD offer any mentorship programs or career workshops specifically for engineering students who want to find employment in the local semiconductor or IoT industries? And I suppose they're also looking to, is there opportunity to collaborate with those kind of industry partners or semiconductor companies for the project part of the degree as well?
If it's related to the ME, then all students who are doing the ME and are going on placements do have formal training in how to prepare a CV, as Marcus said, and they will be pointed to companies in the semiconductor industry as well as others. In terms of the research projects, where typically they're driven by the academics themselves, but the student, if they have been on a placement, may come back with a project that has been inspired by the work they've done with the company. And so we do have some collaborations like that. Not a lot, but that's up to the student. If they're sufficiently motivated and have found a company where they'd like to work, well, that can be arranged.
Great, thank you. And there was one
Sorry, we might also mention that the university itself at a somewhat broader level has an entire office, the careers office, which is there to assist students in preparing resumes, preparing CVs, presentation skills, interview skills, and also indicating which companies they may wish to reach out to. So there's a whole office within the university for that.
Brilliant. Yeah, I think that's really good to highlight. Thank you very much, Paul. And just to say that there was one or two questions related to our ME in biomedical engineering, and unfortunately we didn't have anyone on hand today for the biomedical engineering side. But if anyone has any specific questions related to that, please reach out to myself and Katie, and we can put you in touch with the program director or get you in touch with a student or an alumni from that program for those particular questions, just to highlight that. And then let's just have a look. I think there's one or two more open questions. I think we've answered a good load of them when they were on the research project. I think that's it. I think a lot of the other questions.
Laura, I might just jump in. There was one with regards to the work opportunity after completion.
Oh, yeah, sure.
So it's worth mentioning that we do have a stay-back visa for international students, and this is, the students call it a stay-back visa, but the technical word is a third level kind of graduate scheme. So what this allows basically someone who holds a level 8 or a level 9, which would apply to all the masters we've spoken about today, it allows you to remain in Ireland after completing your studies once you successfully complete them, and then you can work full-time for a specific period without needing further authorization. But what I will do, I think it's a stamp 1G. What I will do is I'm going to pop the link into the chat and you can read that in further detail.
Brilliant. Thank you. And Katie, actually, I might just stick with you for just a second. There was one or two questions on scholarships. Could you explain how the scholarship system for UCD works for applicants?
Absolutely. So there's a couple of scholarships to be aware of. When you make an application and when you get either an offer or a conditional offer, if you're eligible for the program you've applied for, you will automatically be assessed for what we call an international student scholarship. It's referred to as an ISS, and this can vary in amount if you qualify from around €3,000 to €10,000. So you don't need to specifically apply for that, you are assessed. If it's not awarded, it just means you did not meet the minimum criteria. There's also the Global Excellence Scholarship, and they are the very highly competitive scholarships because they are to the value of either 50% or 100% off your tuition fees. The deadlines for all regions have now passed. Not all results are out. Some regions are still being assessed. As you can imagine, we get an awful lot of applications for these. So unless you have already applied for it, unfortunately, the Global Excellence Scholarships are not open, but the ISS are continually open upon application.
That's brilliant. Thank you so much, Katie. So I think that was all the open questions that we haven't really answered for the session today done. So without further ado, I think we'll end the session and the webinar there. Before we wrap up, just to let you know that my colleague Katie did pop her email address and my email address in the chat there. So as I said, if you want to follow up with us up in relation to your application or anything else after today, please reach out to us via email. And then just to thank everyone for tuning in today, for your engagement, for your questions, and a big thank you to our speakers for your insights as well. And I really hope you enjoy the rest of your day. So thank you, everyone.